Okay, so let's finish this problem. We have found g of 0, f of 0, sorry, we need f prime of 0. Okay, so to get f prime of 0, of course, we need f of x. Do not look at this to tell me that f prime of 0 is 0. This is just the output at 0. Okay, it has nothing to do with look, so you got a function right here. Okay, you got a function right here. The output at 0 has nothing to do with the slope of the tangent at 0. Alright, there's no relation. Okay, so how do we find f prime of 0? Well, we need f prime of x. So let's get f prime of x. F of x is 3x squared minus 5x plus g of x. Okay, so we're going to derive each piece. So f prime of x is going to be 6x minus 5 plus g prime of x. Let me make sure I don't have it on my screen right here. 6x minus 5 plus g prime of x. That's right. Okay, alright, so I'm taking, my time. So now I need to figure out g prime of x. Now g prime of x, well, I don't know. What is g of x again? Let's get g of x. G of x is sum from -1 to x squared, square root of 1 minus t squared dt. 1 minus t squared dt. Okay, well, to derive this, of course, you're gonna need the fundamental theorem of calculus, right? We've used it a couple of times. Fundamental theorem of calculus. All right, let's cover it quickly to see what it says. I want a thin one, maybe this one. Okay, so what does the fundamental theorem of calculus says? The second part, okay. Okay, it says that if you look at, okay, let's take a look at this integral right here from a to x of gt dt. What is this? Well, if you give me an x, I will give you an output, right? This will have an output for a given x. Therefore, this is just a function of x. Here I'm going to call it h. This is a function of x. Give me an x and I will tell you what h of x is. This is a function of x, okay? So what does the theorem says? The theorem simply says that the derivative of h is g of x. That's it. Very simple, right? G is a function inside. T doesn't mean anything, okay? This is the same thing as sum from a to x of g of u du, sum from a to x of gp dp. Okay, it means nothing. Okay, you can replace it by whatever you want. This is one version of it. And let me give you another version I gave in class too. I gave 3 versions in class. I'm not going to go with the third one. If now this function of x is equal to sum from a to u of x, okay, of gt dt, then how do you derive h of x? Like this. It's a previous theorem. It's this and the chain rule. Okay, it's really simple to show. So it is g not of x, but at u of x times u prime of x. Okay, you kind of recognize right here the chain rule. All right, that's the formula I'm going to apply for the function we are looking at, which is right here. Okay, so let's see. So g prime of x. Okay, you see right here. This right here is my u of x. This right here is my g of t. Okay, so it is equal to g. Oops, not g like that. G at, not t, but u of x. So x squared for t squared times u prime of x, 2x. Okay, so it is square root of 1 minus x4 times 2x. That's it. That's it. So let's try that right here. So we have 6x minus 5 plus 2x times square root of 1 minus x4. Now we want to evaluate f prime of x at 0. So f prime of 0 is, okay, well, that's 0 right here, minus 5 plus 2 times 0 times 1. Okay, so it's just negative 5. Alright, so now we have everything. We just plug and chug into this equation. We get this piece right now. So we have y minus, I don't remember what was f of 0, pi over 4 equals negative 5x. Okay, that's a completely acceptable form right here. This is actually the point slope form. If you want the slope intercept, just move the pi over 4 plus pi over 4, and that would be the slope intercept. Okay, very similar. Alright, done with this problem. Hope everything is clear so far. Okay, just write the equation of the tangent, figure out the two pieces that you need, and that's it. Okay, alright, so next problem. Here we go, next problem. What's going on here? They're telling us f is a continuous function defined on the closed interval -4, 14. Okay, got it. And the graph of f is given right here. It consists of a semicircle and two line segment. You can see the semicircle and the two line segment. Okay, got it, clear. Alright, so now what? And then they're telling us that g of x is a function defined like that. Now I don't have a an expression of f. Okay, I just have the graph. That's all. Okay. Okay. All right. So what's the question? What is the average value of f over -4, 14? Show your work. Listen up. When you're given a question like that, like in the previous example, okay, in the previous problem, the first thing I do is write the formula. That's the first thing I do. That's the first thing you should do. Find the equation of a tangent. Well, write the formula and see what you need. Okay, right here, find the average value. I'm gonna write the formula and see what I need. So the average value of f, I don't know how to write that. Okay, there may be I don't know of any notation that we use. This is a completely acceptable one, although ad hoc. What is it? By definition, 1 over b minus a, 14 minus -4, and then integral from -4 to 14 of f of t dt. Okay, so this is 1 over 18, sum from -4 to 14 of f of t dt. Now, what is this piece right here? Well, this is a definite integral. What did we say about definite integral? We said there are 4 ways to compute them. Okay, you can do it directly. Well, I can't. I don't have an expression for f. Indirectly, there's no way I'm going to do a substitution. I don't have an expression for f. Okay, 2 more ways. Okay, geometrically or numerically. Now, it's pretty obvious which it should be, because the problem is telling me that the graph of f consists of a semicircle and 2 line segments. So I'm guessing it should be a geometric approach to solving this question. Okay, so let's try that. I know what this represents right here. Okay, this right here, let's write it here. Of f of t dt, that represents the area between the graph and the x-axis. Okay, the area between the graph and the x-axis. I'm not gonna say you count it positive if it's above the x-axis, negative if it's below. Alright, let's take a look at it. Here's my area, so I'm going from -4 to 14 right here. That's the average value they want. Okay, so I see I have this big piece right here, and that's gonna be counted positive, and I have this big piece right here, this little piece right there, that's gonna be counted negative. Okay, all right, how am I gonna get that? Well, let's start with the negative one. That's gonna be pretty straightforward. Change color here, maybe I'll use this. Okay, so what's that? That's triangle 1 2 3 4 5 1 2 3 4, sorry, 4 2, that will be 8 divided by 2 is 4, so that's -4, the area right there. Okay, okay, that's negative. Let's look at that. Here we go again. Oh well, that's the same triangle, right? So this is +4. Okay, it's an algebraic area. This is a trapezoid. It doesn't matter if you don't remember the formula of the trapezoid. You can just count, check it out, like it's made of a square and a same triangle as that, right? 2 by 4, so it's also 4. So this is 8. 4 plus 4, 8. Okay, what about this one? So what do we have here? Let's see, 1 2 3 4 8. 1 2 3 4 5 6 48. So this piece right here is 48. What do we have here? Well, this is a semicircle, so it's going to be 1/2 pi r squared, pi times, and this is 4 squared. 4 squared 16 divided by 2, 8. 8 pi. Okay, I think I got everything. Let's put it all together. Okay, so this area is 1/18 times, okay, times what? Times 8 pi plus 48, 8 pi plus 48. These are counted positive because they are above the x-axis. Plus 8 plus 4, plus 8 plus 4, and then -4 is the only piece left, right? -4. That's it. This cancel. 48 and 8, 56. And so you have 1/18 times 8 pi plus 56. Of course, we can divide by 2, right? That's 9, 4, 28 equals 4 pi plus 28 over 9. Here we go, and this is the average value of the function over the interval 0, -4, 14. Okay. All right. Next question. G of 10. G of 10 equals, well, what's G of x? G of x is f of -4 sum from -4 plus x. Okay, so f of -4 plus sum from -4 to x, so here x is 10, right? X equals 10, of f of t dt. Okay, so we need two things, f of -4 and this integral again via areas for this integral. Okay, f of -4 is right here, it is 6, the value is 6, plus what's the area right here? Sorry, the area is going to 10 right there. So 4 and 8, 12, 12 and 48, 60, 60 plus 8 pi, okay, 60 plus 8 pi, so it is 66 plus 8 pi. Okay, I'm gonna need another video to finish this thing, so I'll just start another video.